Hi everyone, today I will solve Aerospace Engineering GATE 2017 question number 37. A football meant to be thrown at 100 km per hour in sea level air, density equal to 1.22 kg per meter cube, viscosity equal to 1.7 into 10 power minus 5 Newton second per meter square, is to be tested using a 1/4 scale model in a water tunnel. Density equal to 1000 kg per meter cube, viscosity equal to 10 power minus 3 Newton second per meter square. For dynamic similarity, ratio of model force to prototype force is round up to nearest integer. This is a problem of dimensional analysis and we will solve. For reference, you can refer to this NPTEL reference. First, we will talk about dimensional analysis. All the natural laws are independent of any unit of system. So in natural law, we can use the MKS, CGS, FPS, any unit of system and it will work. All correct physical relationships can be stated in dimensionless form. If there is any physical relationship, let's say A plus B equal to C, then it can be written in the dimensional form. If we divide it by C, then it will be A by C plus B by C equal to 1. So according to this dimensional homogeneity, we will talk about later. So this term and this term will have will be non-dimensional less term. So we can write any physical relationship as non-dimensionless form. In any comparison, the unit of items we compared must be the same for the comparison to be valid. If we want to compare this A and B and C term, so the unit of item should be the same and they should be written in the same type of unit system. Dimensional analysis is based on the fact that in an equation dealing with the real physical world, each term must have the same dimension. So this each term will have the same dimension, only then the equation will be valid. We will talk about Buckingham Pi theorem. Let's say there are q1 to qn and variable, and so these terms can be written as the functional form of this function f q1 q2 to qn equal to 0. So this Buckingham Pi theorem states that this n term can be written as the n minus r independent dimensionless parameter group, where r is the number of independent dimensions. These independent dimension depends on the fundamental dimension present in the problem. Each dimensionless parameter group is commonly called a pi group or dimensionless group. Now that we got the n minus r pi group, so we can write the functional relationship as the function of all the pi term, or some one pi term is the function of all the other pi term. These dimensional groups are not unique. So if there is one pi term is pi 1, then there can be one pi term can be 1 by pi 1 or e to the power pi 1. So these are not unique pi term. Each pi group or dimensionless product of are independent physical variable called repeating variable plus one other variable from the remaining variable. Let's say q1 to qr are repeating variable. So pi term can be written as q1 to the power a1, q to the power a2 and qr to the power ar into qr plus 1, where this q1, a1, a2 and ar can be found based on the dimensionless product of all these quantities. Choice of repeating variable should be such that they include all the r dimensions used in the problem. So these repeating variables should contain all the r dimension which is present in the variable, and these variables should be independent of each other. We will talk about principle of similarity. So first we will talk about what is prototype and model. Prototype is the object which is at 1:1 scale under actual flow condition and fluid property, whereas the model is at a different size which is a different flow condition and fluid property. So based on this prototype and model, there are three type of geometric similarity. So three type of similarity. So first, geometric similarity. In geometric similarity, model and prototype would be of the same shape, but model may be scaled by some constant scale factor. So if prototype is some square, then model would also be square, but it might be scaled version. Kinematic similarity. The velocity at any point in the model flow must be proportional by a constant scale factor to the velocity at the corresponding point in prototype. Let's say there is one prototype and one model. So in prototype at the 2 point velocities u1 and u2, and at the corresponding point of the model velocity u1 dash and u2 dash. So ratio of u1 and u2 should be equal to u1 dash and u2 for the kinematic similarity. So for kinematic similarity, it is necessary to have the geometric similarity. Streamline are kinematic phenomena, hence the streamline pattern in the model flow is geometrically scaled copy of that in the prototype flow when kinematic similarity is achieved. So if there is kinematic similarity, then the geometric pattern of the streamline will be the same for model and prototype. It is only the scaled version of each other. Dynamic similarity achieved when all forces in the model flow scale by a constant factor to corresponding force in the prototype. Let's say there are two forces, inertia force and viscous force. The ratio of these two in model will be equal to ratio of these two in the prototype. If a flow is dynamic similar, then it is kinematic similar and geometric similar. To ensure the complete similarity, the model and prototype must be geometrically similar, and all independent pi group must match between the model and prototype. So if there is pi 1 for model should be pi 1 of the prototype, similarly pi 2 of the model should be similar to pi 2 of the prototype, and so on. So now we will start solving the problem. So first we will select all the variable and parameter which are present in the problem. So as seen that we have given velocity, density, viscosity, dimension, and force. All the variables are force, viscosity, density, viscosity, velocity, and football is circular, so we have taken the diameter as the dimension. So we will write the function relationship as force equal to function of density, viscosity, velocity, and diameter. So now we have to select the repeating variable. So generally in fluid flow, if there is velocity and one difference length and one fluid property, then we can directly select these three as the repeating variable. But if there is not, or we can select using the according to dimension. So first we will find out what are the dimensions present in the fluid flow. So first we will write the dimension of all the variable. This all the dimensions are written in the bracket. So force has a dimension of mLt minus 2. Density has the dimension of ml minus 3. Viscosity ml minus 1 t minus 1. Velocity lt minus 1. Diameter L. So there are three types of fundamental dimension: mass, length, and time. So we have to choose three repeating variables. So we have chosen rho, u, and d. So if you want to check if these three are independent, so we will make one matrix of rho, u and d. So power of m is in the row is 1 L minus 3 T0 U and minus 1 for T 0 1 0. So we write a matrix for all the power present in M and T for all the three variables which we are choosing. So if we find the determinant of this matrix, then it will be equal to 1. If this determinant is non-zero, then all our dimension are all our variables which we have chosen are independent of each other, and we can choose these as the repeating variable. And if it is 0 by chance, then we have to choose the variables again. So now we have total number of variable n equal to 5 and repeating variable r equal to 3. So we will have n minus r equal to 2 pi terms. So we have to find the pi terms. So first pi term will be the combination of force and other repeating variable, rho 1, rho to the power a1, rho to the power b1 and d to the power c1. We will write the dimension of all the terms. So dimension of both sides should be equal. Dimension of pi term is the 0, 1. So we m0, l0, t0. Dimension of force is m, l, t minus 2. Density m, l minus 3. Velocity l, t minus 1. Diameter l. So if we combine the power, then it will be m to the power 1 plus a1, l to the power 1 minus 3 a1 plus v1 plus c1, t to the power minus 2 minus v1. So all these power should be 0 for non-dimensional t. So a1 equal to minus 1, v1 equal to minus 2 and c1 equal to, if we check it here, then c1 equal to minus 2. So our first pi term will be f upon rho u square d square. We will find the second pi term which will be the combination of viscosity and density, velocity and diameter. Similarly, we will write the dimensions of all the terms. For pi term it will be m0, l0, t0, and viscosity it will be m, l minus 1, t minus 1, density m, l minus 3, velocity l, t minus 1, and diameter l. If we combine the dimension, it will be m 1 plus a2, l minus 1 minus 3 a2 plus v2 plus c2, t minus 1 minus v2. If we solve, then if we get all the power equal to 0, then we will get a2 equal to minus 1, v2 equal to minus 1, c2 equal to minus 1. So we will get the pi term pi2 equal to mu upon rho u d. And if we see that rho u d upon mu equal to 1 by m of mu, but we will use this only. Now we will state the dimensionless relationship. So it was pi1 equal to function of pi2. So pi1 is the f upon rho u square d square, and pi2 is mu upon rho u d. Now we will apply the dynamic similarity in the problem. So first we will equate this term pi2 for model equal to pi2 for prototype. So mu m upon rho m um dm equal to mu p upon rho p up and dp. We find the ratio of dm and dp, which will be um rho p dm upon mu p rho m dm. This will be the first equation. Now we will equate the other pi term, phi1 for model equal to phi1 for type. So we will equate it force Fm upon rho m square dm square equal to Fp upon rho p up square dp square. We have to find the ratio of F upon Fm upon Fp. So it will be rho m upon rho p dm upon up square dm upon dp square. From first equation we will substitute um upon up. So we will get F upon Fm upon Fp equal to rho p upon rho m upon rho p into mu upon up rho p and rho m dp upon dm whole square into dm upon dp square. This dm square and dp square will cancel and we will get rho p upon rho m into mu m upon up square. So from the problem we will put the value of rho p, rho m, mu m and up. Rho p is 1.22, rho m is 1000, mu m is 10 to the power minus 3 and up is 1.78 and 10 to the power minus 5. If we solve it, then we will get 12.2 upon 1.78 square, which will be 3.85. So in integer it will be 4. This will be the answer. Thank you.